right, thanks. This is $1 Billion Foresight. I'm Richard Feldman. So I want to start with a question. Quick show of hands. How many people have ever encountered this error? Okay, that's most. How about this one or this one? Anybody else? Yeah. Okay. So between those, I think that's basically everyone. So believe it or not, these errors didn't always happen to everyone. They weren't always so common as they are today. There was a time before null was really popular, and null reference errors like this happened to everyone. And there was a guy who introduced this named Sir Tony Hoare, knighted for his contributions to programming. He made a lot of contributions to programming, most of which were good. He invented quicksort, for example. But this one he kind of regrets. In fact, he refers to it as his $1 billion mistake in this talk from a few years ago. And he considers it his $1 billion mistake because he believes that his introducing null references, or popularizing them back in the 1960s, has since caused about $1 billion in economic damage. And it's because of errors like that and because of similar problems that null has. So I thought about this question of like first of all, is that a reasonable figure? Like $1 billion? Really? That's so much money for adding a feature to a programming language, of like introducing something new. That's a lot of money to just go up in smoke for something like that. And then I also asked this question, like, okay, so if that's $1 billion mistake, how do you go in the other direction? Like how do you prevent a $1 billion mistake? How do you have the foresight to say, oh, you know, we've seen this before, like maybe we can do better. Can we do better? And I was kind of asking these questions and thinking back on, well, first of all, is it actually $1 billion? Well, what has it been to me personally? What has my experience been with null and the impact that it's had on my career and my friends' careers and my co-workers' careers? And I started thinking about this, and I started thinking about this story and see if this resonates with you. So imagine like I'm building a checkout system. I'm working on the front end, and I've got this system. It's got discounts. We're selling stuff. It's got prices, all these different things. And at some point, I get a bug report. So a user writes in, and you know how bug reports go. They're never really specific. They're just kind of saying like, hey, something broke. But this one is actually a little bit more specific. They have a particular complaint about what broke, and what they say is, when I get to the end of the checkout and it tells me my final price, like the final total, the amount of money that it says I'm supposed to pay is $NAN, and I don't know how to pay that. That's a weird amount of money to me. I have like a number of dollars, but this is like, isn't that a bread? Like how do you pay NAN dollars? And so I get this bug report and I look at it and I think, okay, I know what happened. So there's like some math issue somewhere, and something ended up being not a number, and then not a number got like two-stringed into NAN, and NAN got displayed to them. So I'm just going to have to go track this down. So I'm like, all right, so how did NAN end up making it all the way through my JavaScript code to the end user so that they saw this and experienced this bug? So I'm like, all right, well, I look at the code that computes the final price that displays to the user, and I see that this is the calculation. It's total price plus discount. So we're running this promotion right now, and it's there's like a lot of like one-off logic that we kind of implemented just for this one particular promotion. So there's this discount. There's a couple of things that go into the discount, and I'm like, okay, so one of these two is potentially to blame for my user seeing NAN. It turns out it's discount. So the discount value is NAN, and in JavaScript, anytime you add NAN to a number, even if that's a totally valid number, you still get NAN out the other side. So NAN just kind of propagates like that. So that's why the end price was NAN. So I was like, okay, well, fair enough. How come discount is NAN? So I dig a little bit deeper and realize, okay, the reason the discount is NAN, thus causing the whole thing to be NAN, is that I'm adding tax to promo discount. And although promo discount is a perfectly valid number, tax is NAN. So it goes like one step deeper. It's like I got an NAN plus another number, that turns into an NAN, which then gets added to another valid number, but the NAN just keeps snaking through. So I have to keep digging deeper and being like, where is it coming from? Where's the originator of this NAN? Where is patient zero of this virus that's infecting my code? This pathogen. And I dig one step deeper and I see, okay, total tax minus state tax equals tax, and that was going into my calculation. And total tax is a valid number, and state tax is null. Why is it null? And how did that result in NAN? Well, in JavaScript, when you add null to NaN. And actually what I mean is really like undefined, because in JavaScript, like undefined and null are kind of like two different versions of the same thing. So for purposes of this talk, we'll say it's null, but really in JavaScript, undefined is what would get me this behavior. But it's talk about null, so we'll just call it null. So when you add that to, or subtract that from total tax, you get NaN, and that's patient 0. That's the start of this pathogen that infects everything. And it all happens because state tax is equal to this array I have of taxes, bracket 1. So for some reason, when I go to get that value out of the taxes, it's not there. There's a null there instead. Okay, so why is that? And let me just take a quick detour into pathogen containment in a couple of different languages, because how I find out the answer to this question is different depending on the language I'm using. So if I'm using JavaScript versus Ruby versus Python, I actually have a different experience going through and answering this question. So in JavaScript, I got state tax equals taxes bracket 1, and somehow that gives me back undefined, which again, for purposes of this talk, we're just going to refer to as null. And then I say total tax minus state tax, and that gives me not a number. Okay, so that's led to all of the work I've done up to this point is because JavaScript gives me NaN here. Now in Ruby, first of all, one difference here is that Ruby uses snake case instead of camel case. Okay, fair enough. So it'd be state underscore tax in Ruby equals taxes bracket 1. This is going to give me back nil, which again, for purposes of this talk, let's just call it null. So far, it's the same thing. I looked up something in the taxes array, and I got back null. And then I say total tax minus state tax to try and compute the next thing, and here's where Ruby does something different. Instead of giving me NaN, Ruby gives me a type error. It blows up, runtime exception. Now, the interesting thing about this is that in comparison to NaN, I don't have that whole investigation that I just did before this. Like all of that work that I did to trace back like the NaN pathogen that was snaking through all my arithmetic, none of that happens in the Ruby version. Because it errors out early. It errors out right when I try to go and do that first subtraction problem. It says, no, stop, type error. Interesting. So this is better for a couple of reasons. Number one, I think it's better for the end user. If I'm using a checkout system and it says $NaN, I'm like, they don't know what they're doing over there. What is this? This is bizarre. Like somebody has clearly made a horrible mistake. Whereas if I get an error message that just says like, hey, sorry, the site is unavailable right now, please contact support or something like that, I'm like, oh, it's probably like squirrels chewing on network cables or something. This is some computer thing happened. It's probably not their fault. And whereas, in the case of NaN, I just lose confidence in the people operating this website. So I think it's better for the end user, and it's better for the programmer in at least two ways. Number one, you don't have to do that whole investigation of the null, infecting all these other things and sort of like tracing the infection back to the root. But number two, you're probably going to get like a stack trace with this and like a line number. It's actually most likely going to tell you the exact point in the code where the problem happened, so you can just jump right there and start working on figuring out a solution for it. So that's better, and Python takes it even one step further. In Python, if I do state tax equals taxes bracket 1, and taxes is an empty array, there's nothing in there, it's just going to be an index error. So assuming that's the problem in all of these cases, assuming the problem is that we don't have anything in that array of taxes, like maybe it's like the US, we have some areas where there's like no sales tax because the city doesn't have any tax and the state doesn't have any tax, and it's entirely possible that taxes array is empty, and that I would just get an index error out of Python. Okay, so in that case, I wouldn't even have to take the one step that I did in Ruby. This would take me right to the problem. The problem is the array is empty. Okay, so Python would have helped me out more than Ruby, which would have helped me out more than JavaScript, but that doesn't answer the question of, like, does that actually help me out here? Like, is taxes actually an empty array? Is that the source of my problem? So in JavaScript, I go and investigate that. Turns out, no, there's actually 3 things in the taxes array, so that's not the problem. All right, so what is the problem? Like, there are taxes in there, but it's still null. So it's like, why is this happening? Okay, I know what the problem has to be. The problem has to be that null value was in the array intentionally. There are 3 things in the array, but one of the things in the array is the actual value null. That's possible, and I guess I've ruled out the other possibility. So okay, let's pursue that. Let's see if that's the answer. Or we can just do this. Say, you know what? I found the source of the null. I know that all the problems happen after this. That's like the end symptom of the user. Maybe I just don't care about the root cause anymore. I've spent enough of my life on this. I'm just going to say or 0, And in JavaScript, if you have null or 0, you get back 0. So then the state tax is now 0 instead of null. And then when I add it to this thing, or subtract it from total tax, it's no longer going to give me not a number. It's just going to work. And then this thing's going to work. And then finally this thing's going to work, and I can go home. All right. So that sounds like that works, but it kind of bothers me, right? Like I just kind of hacked around the problem. Like, wouldn't it be great if in addition to just like fixing the bug, if I could like, you know, prevent it in the future and not like have to incinerate all the money that I just incinerated going through all these steps. Like I would much rather like prevent this type of thing proactively and not have to do all of these steps again in the future to prevent this from happening to another user. So we come back to this, and I'm like, all right, I'm going to be proactive. I'm gonna dig deeper. I'm going to find the root cause, and I'm going to prevent it. Okay, let's dig a little bit deeper. So we know that this was null, and then null or 0 give us back 0, and that solves the problem. But it doesn't tell us why this was null. All right, so why was it null? Okay, so where this taxes array comes from is we have this get taxes function, and it takes some JSON that we got from the server, and then it returns an array of these things. So it returns json.tax.national, json.tax.state, and json.tax.city. And it's that middle one that is null in this case, because that's what taxes bracket 1 is going to give me, that json.tax.state. So I could say, okay, well, I could make this a little bit better for anyone who's using this in the future by just moving the or. I could just put it there, and now anybody who calls this function, not just this code, is going to be, you know, prevented from having that problem. So that's pretty good. I'm feeling pretty good about that. And I'm like, well, now I'm not feeling great about that first one. It doesn't have the check. Like, what if somebody comes along, like one of my coworkers ends up changing it so it doesn't come from get taxes anymore, it comes from somewhere else. And what if that somewhere else gives it a null? Now then we're back to square one. It's going to crash again, or give a NaN. All right, I'll just do it in both places. And actually, now that I'm thinking about it, like, what if national is null or city? You know what? I better just go ahead and like put it in all three places. Okay, now we're feeling better about this. Okay, this is good code. Okay, all right. So I'm not like thrilled that I did this, but at least I'm like, hey, you know what? It's going to solve the problem, and it's going to solve the problem in more places than just the immediate proximal bug fix. So it feels less hacky. So okay, so then I'm like, but why? Like, why are these null in the first place? Like, I gotta know. Like, what caused them to be null? Like, when they came back from the server. So this JSON comes from this fetch adjustments from server thing, which gets the taxes as well as some other stuff. I'm not sure what the other stuff is, but I'll take a look. So here's the JSON we got. It's got an object called tax, which has national at 2.3, state at null. Okay, there's our null. City at 0.4, and then there's this other thing down below called system, which is also null. What? That's probably going to cause the same kind of problem. I don't have a bug report for that, but like if I really want to make the system robust, shouldn't I go and like or that to 0? But to 0 even makes, look, what is a system? Is it supposed to be a number? So should I or it to empty string? What, like, I don't want to have the same problem with the system thing that I've been having with text, but like I don't even know how to be defensive about that. I see that it's null, but like what's it supposed to be? Okay, you know what? No, this is a rabbit hole. I'm not going to go down this rabbit hole. I've learned that in my career. I'm just going to stay on focus. Okay, focus on the state. Why is state null? Okay, so I look at the server, and our server is written in Node, so it's the same language, so I can kind of look at this code with the same pair of eyes. And I'm like, tax equals db.fetch, and then the way that our database API works is you give it, like, the tax tells you, this is the object that I want, and I want you to go put something in the tax field, and then here are the things that I want to go into that. I want national, state, and city. Like, pull those out of the database and then put them in this tax thing. I'm like, okay. So state comes back null. That's the explanation. Cool. And then I stringify it, and then it's like tax is tax, and system is system. Still don't know where that system thing's coming from. It's got to be somewhere else in my server code. But again, rabbit hole. Not going to go down it. Okay. Then I realized, wait a minute. Before I finish up with the state thing, it's possible I know that the db.fetch is allowed to return null. Like that's in the docs for db.fetch. So it's entirely possible that this stringify thing is going to say tax is null. Not just that tax.state is null, but the entire tax object is null. Wait a minute. If tax is null, then here, that's going to be null, and this is going to blow up. Like this whole thing is going to throw a runtime exception. Okay. Wait. I know what to do. So I'm going to or json.tax with an object that's got zeros for all of these. And then, if the database comes back with null, I'm protected, right? I got zeros in all those places, and then we'll do some extra ors for zeros, but that's okay, that's fine. And I'm like, all right, now I can go back and try and figure out why it was null in the data. Wait. Okay. But what if the JSON itself is null? Okay, one more. All right, now we're good. Now it's good code. Okay. So like, okay, so this is like, it's safer code, but like I'm not living my best life here, you know? Like, I'm not happy with how this ended up. Like, I actually, honestly, I liked it better before. When I knew there were all these risks, I couldn't see them, but like, man, was it nicer to look at. I could at least comprehend that code. I could look at it and figure out what it was doing. When I look at this, I'm just like, there's just so much like this noise. I can't figure it out. It's just painful. So, maybe the answer is that this is a JavaScript problem, and like there's tooling out there that I can use to improve this. Maybe TypeScript is the answer. Maybe like I can get some TypeScript going and I can solve this problem. So first of all, I might look at the typing the JSON that comes from the server, but then I kind of like talk to my buddy who does TypeScript, and he's like, so like what we do with like typing JSON from the server is pretty much we just like say it's going to be this type, and then like sometimes it's not, and it just accepts it. So it's kind of a pinky swear sort of typing thing. Like, all right, well, in those cases, I'll use the or zero, but there's got to be something I can do about the null thing, right? It's like, yeah, actually there is. There's this cool compiler flag called strict null checks. And when you enable this compiler flag, what TypeScript will do is it'll go through and it'll check all your code and see all the places where you could potentially have a null value. And if you could potentially have a null value, then it's going to make you deal with it if you say this thing is supposed to be not nullable. So I could say, like, let state tax : number, which in TypeScript means this thing's got to be a number. And then when I do this, if I don't properly handle this, like an or zero or a conditional or something, then TypeScript will give me an error. And it'll say, like, no, you said no null checks. Like, this is not going to fly. So then it could tell me all the places that I need to do those checks rather than having to litter them defensively all over my code just in case. So that'd be a big improvement. That other code would have gotten a lot cleaner. I'd much rather get an error for this at build time than deal with all the consequences of having to be so defensive. Here's the problem, though. All right, so like here's where we are with our JavaScript code base, and then we like took all our JS files and converted them to TS files and ran it through with strict null check, and then just like saw how many errors there were. It was a big number. So like if this is where we are, like this is the world where we can enable that and like it passes on our build. Like there's this huge amount of work we'd have to do. Like this is like, I mean, the amount of money it's going to cost to get us from here to there is just, I mean, it'll take months. I mean, it's not unachievable, but I mean, I'm starting to understand where this $1 billion number comes from. Like this is just a huge amount of work to convert our existing code to that. But okay, let's say that we do. Let's say we make the investment. We just get null out of the code base, and then we turn on the flag, and then from then on, we're good. Because anytime anyone tries to introduce a new null and accidentally has it propagate, it'll catch it right away, and it'll say, hey, you forgot to handle it here, and here. And then we'll go and make the changes. It'll be good. Our code won't be super defensive. We won't have these NaN problems or these null problems, and everything will be good. As long as we don't have any dependencies. So there's this problem where we have lots of dependencies. We use NPM, and we have all these other packages that we use. Most of them are not typed, but some of them are. Like this third-party tax database thing that we're considering using to go get our state taxes. This one has entries in definitely typed, or definitively typed, something that starts with a D and a T. And that's got TypeScript typings for a bunch of NPM packages. So that means we can go get stuff from there and find out what the TypeScript typings are. And then we can use that with our code base, which we've verified ourselves doesn't have any nulls, and it all type checks, and it's all good. And then also we can use definitively typed to check the third-party code and make sure that it's all good too. There's no way that they can like cheat, right? There's no way that they can like actually have nulls but say that they don't and it compiles anyway. Okay, it turns out there totally is. It's called any. And it's just like the pathogen to end all pathogens. And it's just like, anybody can use it. And you just basically where you say, like, instead of colon number, you say colon any. It could be null, undefined, not a number, it could be whatever it wants. And that's true of everything in that whole package ecosystem. So even if we get it all out of our code base, and even if we get the strict null checks going, we still potentially can have nulls sneaking into our code and then showing up, and then we have to trace it down just like before, because any of that could come from third-party stuff. But I have the solution. Boom. That's what we're going to do. Just anytime it's third-party code, and then you're like, how do you tell if it's third-party code? Just, you know. Okay, just know that. I don't know. Okay. So, yeah, is it $1 billion mistake? I'm like pretty quickly concluding, yeah. Like I think, like if I think about me and my friends and their coworkers and my coworkers, like everybody put together, like yeah, over the past 50 years, I totally buy that that's a $1 billion mistake. So like, why do we even have this? Like if it's just such a mistake, if it's just such a universally bad thing, if it just causes all these problems, like why do we bother? Why even use this thing in the first place? Like, what is it actually genuinely good for, y'all? So here's an example of where I would say null is actually an improvement over the alternative. So in JavaScript, if you take a string and you call index of on it and you pass it some other string, if that other string is not found in there, it'll give you back an index of -1. That's not great. I mean, I can think of a lot of like potential problems. Like we saw the consequences of like accidentally having a null and then multiplying that or using that in arithmetic and then ending up with not a number which propagates through and then ends up as the price for an end user thing. I can think of worse things than the user seeing $NaN. The user seeing $sign and a negative number, considerably worse than NaN. So like this permits that. I mean that's a potential problem that could happen. And in fact, even if I had TypeScript would be like, oh yeah, I agree, that's a number, no problem. Proceed. So that's kind of not ideal, and I would argue that Ruby's equivalent, which is .index, it gives back nil because it's Ruby, but I think in this case giving back null is an improvement. I mean I genuinely think that. So clearly there are use cases for at least the concept of representing like the absence of a value or something went wrong but in a recoverable way, like where we don't need to crash, we can just represent it with a value that something bad happened or something unexpected happened. Okay, so does that mean we're just stuck with the $1 billion mistake? It's like it's useful, so we got to use it. So like there's no alternative but not to use it. But using it means we have all these problems. We have to do all this defensive programming or spend all this money like trying to get something that only partially works. So we're still going to end up using or zero in a bunch of places, just maybe not as many places. I mean, are we just stuck? I mean, is there no better way? Actually, there totally is a better way. So I got into this programming language called Elm, and Elm doesn't have the $1 billion mistake. It just doesn't have null. It doesn't exist. It's like the guy who made it, he like had the foresight or at least the like looking around and maybe even just watching Tony Hoare's talk about where he called it the $1 billion mistake. He was like, yeah, I'm not going to put this in my programming language. We're just not going to have it. Okay, so then what? Then I returned to this time of great innocence in my programming life, where when I first got started, I had no idea like what programming was going to be like as a career, and I was just like, I'm going to build things and it's going to work forever. And I just had no idea what debugging was, or like maintenance was, or maintainability, and none of these things. I was just completely innocent of all these things. I was just like run, like yeah, I'm just building stuff, and I'll never have to maintain it. And then and it was super fun. And then like reality hit, and I learned about null and like it crashes and all these problems and bugs and stuff. And eventually I kind of like lost that. Until I used Elm, and I just felt like I was just like back in year one. I was like, yeah, I can just like build stuff, and not at first. Like at first, I was kind of like, I should do a null check here. There's no null in the language, so can I just not do that? Do I just like, no reason to worry you? Oh, okay. Well, maybe I can like, I'll just like write some more code, and then like, oh, here's a no. Oh. I can, okay. And eventually I just started, I'm just running again. I'm just cranking out code and just like shipping stuff, and I'm just like, and it just like doesn't break. It's amazing. And I just felt like a kid again. And it was just unbelievably nice. And then I introduced it to my coworkers, and now they all love it. and we've just been like just having this like amazing like Elm party for like the past 3 years. It's just been fantastic. By the way, the company is NoRedInk, and we're hiring. I say this a lot at talks, but at this particular talk I can say we currently have only one employee of Italian descent, and I think we should have more. So please apply. We do a lot of remote stuff. So we're like having this big Elm party, and I think this kind of begs the question, okay, but like we don't have null. So like, what do we do instead? Like, what do we do about the cases where there is an absence of a value? Like, how do we handle that array situation from earlier? How do we handle the index of situation? Like, we still like need that functionality. I mean, we got to build stuff. We're going to ship software. What do we do without this thing that like we've been using for this purpose for the past like several decades? Well, let's look at some specific examples. So index of, right? JavaScript says -1. I don't think that's great. Ruby says null. I don't think that's great either. I mean, it's better, but it's still not great. Here's what Elm does. Elm doesn't call it index or index of. Elm calls it indexes. And it doesn't just give you back the first one it finds, it just gives you back all the ones that it finds. Or, if it doesn't find any, it just gives you back an empty list. So just this one API change, and it's like, oh, actually, like, this is something that I already know how to handle. It's totally fine. And in fact, this is more useful because if there are multiple matches, I actually find out about them and I find out what they all are. Huh. And this is not like a language design thing. This is just a library design thing, right? If you're making a library, you have this choice. You can, in any of these languages, you can implement this. But I think this is the type of thing that only emerges when you already say, I'm not putting null in my language, and then you are faced with these questions, and you're like, what do I do if I want to look up the index of a string in another string? And I think this sort of leads to, in a lot of cases, just nicer solutions, just from putting that constraint on yourself and learning from the past and saying, well, we've seen what that leads to, so we can now have the foresight not to do it again. Okay, what about this one? So we talked about, just to kind of condense it, we had like total tax minus tax brackets 1, and in JavaScript that gave us NaN. In Ruby, that gave us a type error, but it gave us a type error at the first spot rather than the second spot. And Python gave us an index error immediately when we did taxes bracket 1. So what does Elm do in this case? So Elm looks a little bit different. You say array.get instead of the bracket syntax. Total tax minus array.get 1 taxes. This actually gives us a compilation error. This won't compile. How does that work? So basically, this is the error you see. It says the right side of minus is causing a type mismatch. So Elm does type checking, kind of like TypeScript, except not like TypeScript because it's like pretty different. Here's an example of that. Total tax minus array.get 1 taxes. We got this little like red underline explaining like here's the problem. Minus is expecting the right side to be a float, but the right side is maybe float. So what's a maybe float? Maybe is a container that represents the possibility that you don't have a value there. So rather than null being this pervasive, infectious thing that is everywhere in your code or maybe nowhere in your code and you have no visibility into when it is or is not there, maybe is a container that's only present, only involved in cases where there's the possibility that it's not there, such as getting something out of an array. I mean, yeah, maybe there's nothing at that index and maybe represents that possibility. So before I can use this maybe, I have to extract the value from the container. And Elm also has compile time checking, kind of like TypeScript does, to make sure that I have to do that. I have to take the value out of the maybe and handle both possibilities, the possibility that's there and the possibility that's not there. I have to write code that handles both of those in order for this to compile. So basically, instead of having null, I just have a container. And because I have a container instead of null, that in conjunction with Elm's compile time checking means that I can never forget to handle this. Ever. I mean, it just can't happen. So not only do I not have to be defensive, in all these different places, I can't be defensive. Like I can't do that or 0 because that or 0 wouldn't make any sense. There's no null for it to or out of the way. So I've been working in NoRedInk using Elm for 3 years. We've now got 250,000 lines of Elm in production. And over the course of those 3 years, we've been using things like maybe. There's other variants on this to represent different types of things that can potentially go wrong. There's result, request, and tax. A task. And I looked at, like, over the course of these 3 years, like how often does these actually come up? Like, how much, guarding against the possibility of the absence of a value are we doing? Because we saw in the JavaScript world, it could potentially be just, like, dominating your function. It's just the whole thing. But in the Elm world, I just, like, looked it up. It's like 6% of our return values. That's it. Like almost never do we actually need to do it. But only if not having null gives us the confidence to say that, yeah, we only need to do it in those 6% of places. That's the way that we can get like the safety that we want to have things work, still represent the absence of values, and not have to be so defensive, and not have to have things crash or have these like viral propagations of problems. Another thing about us in these 250,000 lines is that we've never had like null errors. Like those things we talked about at the beginning just hasn't happened to us. We've never had a null crash, a null pointer exception, none error, any variation of that, nil error. Just hasn't happened because again, it's just not in the language. It's just like those things can't happen to us anymore. We've eradicated the virus. We've crossed the canyon. It's just not there anymore. And what's even better about this is that Elm has its own package ecosystem. And in that package ecosystem, there's also no null. It's all Elm code. Every package that we depend on in all these 250,000 lines of code, and believe me, there's a lot of packages we depend on, all of them have the same characteristic. So when we're using third-party code, we don't have to be like, hang on, are they cheating? Are they claiming to be one thing but actually being another thing? No, they're not. None of them are. They just like don't have that ability. Especially because the package manager actually like checks that the code compiles before it'll even let you upload it. There's some other cool stuff. Like it also enforces semantic versioning. But if you want to learn more about that, you're probably gonna have to go to Eric's talk about Elm later today. So like putting these together, we've just had this like amazing code base that's just super fun to work on. We can just ship stuff all the time, and it just kind of doesn't break. It's pretty great. By the way, if you're interested in learning about Elm, I recommend this book, Elm in Action. I'm writing it, and also Manning, the publisher, was generous enough to give us a discount code. This is for the whole conference, so CTW Codemotion IT18, and that'll get you 40% off. Ah, man. Okay. 40% off. Not just this book, but also any of Manning's books. So that's a good code if you want to get some Manning stuff. Okay. So way back in the beginning, I asked how many people had encountered one of these, one of these, one of these, and it's pretty much all of us, right? This is something that affects us. And you know, is it $1 billion? I mean, technically we'll never know, but yeah, I really think that's like probably the lower bound. I bet it's actually a lot higher than that. And as to the question of like, you know, do we have to suffer this? Like, no. I think I got an answer to like what can we do to have the $1 billion foresight not to have null and to still have a good experience. The answer is just use a language that doesn't have it. Thanks. So they didn't tell me I couldn't take questions, so if anyone's got any questions, hit me up. Got a couple minutes, according to my clock. Or no questions. Great, thanks.